out today. Today is going to be the last lesson, and we'll be just talking about various bits that we haven't touched on so far that I think are either important or interesting. And yeah, feel free to interrupt me and feel free to ask questions. I will probably ask you what you want to talk about because I think I have too much stuff. So let me share my screen. And the first question will be, would you like to start with functional programming in JavaScript, with or with mobile development, or with browser testing? Which one of those three would you prefer to start with?
Mobile development or browser testing works for me.
Yeah,
I'd say mobile development.
Yeah, okay, good. So let's skip functional programming for now. Good. So when it comes to deploying to mobile, there's a new ecosystem available to us. It used to be that you had to write Java code for Android and Objective-C for iOS, but that's changing. And there's quite a few solutions for us to write HTML, CSS, JavaScript, and make that a native application. So I think there are 3 good solutions, and there might be more, but I think those are the best solution and the best solutions that you can just pick and then deploy your app to mobile. And the idea here is that we want to utilize our web development skills to build a native app. So the 3 solutions I see are using Cordova, or something like React Native, or going the route of the progressive web app, okay, which isn't technically mobile development, but it can be used like that. So Cordova is really just a layer, and it will take your app and it will wrap it into a browser view or a web view. But basically, your app becomes a browser, and your users can install it from the App Store. They can run it. They can do everything they can do with an app, but it's really just another browser. Right? They won't really notice that this is what it is, but it's just a web view. Okay, and so that allows you to run HTML, JavaScript, CSS, just like if you were doing a mobile website. But if you package your app as a native app, then you will also have access to the native APIs. Right? So if you want to access the camera, the file system, things like that, you'll be able to do that. So I can show you what that looks like in a moment. So if you have to make a choice between these 3 alternatives, I think Cordova is quite good. It works well. It supports a lot of platforms. So if you want to install the app on multiple platforms, that's probably a good choice. And it is strictly web technologies. It's real HTML, it's real JavaScript, it's real CSS. So everything you know about these technologies you can apply here. You won't have to learn anything else or learn it in a different way or be aware of some gotchas. It'll all be pretty straightforward. Good. The main con, I think, is performance, which is you're just going to have browser performance. And if you want to do anything complicated, and you might be looking for a plugin, maybe you want to share a file with a different app on the phone, so that would require a plugin. And in my experience, looking for these plugins, it's not so great. There's not many, and those that are there aren't maintained or aren't looking great. So that's not great. But still, if you have a simple application that doesn't require extreme performance, I think it's a great choice. And yeah, and it's pretty easy to get started. So you can try these commands here if you'd like. Let me show you what that gives us. Let's see. Cordova. Yeah, good. So I'm just going to open that in Atom. So I installed Cordova. I generated an application, so the skeleton of the code, and I added a platform. Here I added Android. All right, so you can add iOS, you can add something else, BlackBerry, Windows. You can also add the browser. for you to test on your desktop. That's pretty useful. And then once you've done that, you can just run the app on your phone. Okay, and this is what the code looks like in its simplest form. Okay, so everything in 3Ws is going to be served as the website, and index.html is what the app is going to open. Right, so this is the entry point for your app. And so here you can do whatever you want. You can use Angular, you can use React, you can use Backbone. You can just pull in dependencies. You can use any framework that you want, and you can just offer an experience, a good web experience here. What else is interesting here? And yeah, if you look at platforms, that's where you'll have your code for the different platforms. But hopefully, you won't have a lot of code that is platform specific because it's really just web technologies, right? So they should all be platform agnostic. If you have to write a plugin, then you might have to resort to Java or Swift, something like this, and that will be platform specific. But otherwise, you should stick to JavaScript, HTML, that kind of thing. And that's it. And you can configure your app. You can give it an icon. It's pretty simple. And give it a name, give it a description, that kind of thing. So that's all in the config XML. And there's a couple different XML files depending on what you need to do. And if you want to run that on your phone, it's really simple. You can just do Cordova run Android. And I have my phone plugged in right now. So it will detect it and install the app on the phone.
That's super cool.
Mm-hmm. Yeah. So you see here deploying to device. So that's going straight to the phone, and I can see it now on my phone. I have the Cordova icon here. It's hard for me to show you, but you can just have a look at the screenshot in the class notes. Let me just show you the coolest feature, which is debugging. All right. So here I'm in Chrome, and I get to go to Chrome://inspect. Okay, and here I see a list of either my browser tabs or my apps, my web views. And if I click inspect, I get DevTools onto my app. This is what my phone is showing right now. So here I can do whatever I want. I really have DevTools open for this app, just like a normal website, but I'm actually controlling my phone. So if I do alert hello, I'm seeing an alert now on my phone. I have to say okay. And then you can manipulate your code in here. You can troubleshoot in here. You can debug. You can do all the things that you normally do. You can profile, that kind of thing. So all the technologies that we've used during the course can be used here as well. It works really well. Good. So that's one alternative. Okay, let me close that for now. And it's a good one, unless you need extreme performance, in which case probably React Native is better. So React Native is this new thing from Facebook. It uses React, and it kind of fakes the web. So you can use HTML and JavaScript and CSS, sort of, and then React Native has a lot of smarts, and it'll take your code and it will transform it into native code. So the output of it, at the end, you'll be running native code. So you can offer normal native experiences, and you'll get the native performance, which is good. So that's what's good. That's what's good. It's new and it's kind of popular. It's easy to find resources to learn React Native. It's native and performance good. On the negative side, it really just supports iOS and Android. The docs mention Windows, but it's almost in passing. I'm not actually quite sure if this works well. By Windows, I guess I mean the mobile, Windows Mobile. And yeah, and you'll have to be aware of some gotchas because it really looks like HTML, CSS, JavaScript, but you'll have to learn the differences. Right? So it's like two languages that look almost the same, except that there's going to be gotchas. And then yeah, and if you're not interested in using React, you really just have to use it for this. So that's a negative as well. And that's it. So React Native works, just to get set up, it works in a similar way. So you can have a look at these commands here. And yeah, so you can just add the package, use their command line executable there, and use the init command, create your own code, and then you can just deploy it onto your phone. Okay, that works well. Let me just show you what the skeleton is going to look like. It's a bit small. Okay, so good. So this is the native React Native skeleton application. Okay, and you'll find different code for different platforms, right? So you have Android here, iOS here, and you'll have the entry point for each platform here. So you have index Android.js and index iOS.js. Right? So those are the two entry points, and the idea here is that you'll be building components, so normal React components, and you will just add them to your app as you see fit. And all those components will be shared, hopefully, between the different platforms, whether it's iOS or Android, but the entry point will be different. So this is the iOS entry point, and here, I mean, you can use your components. So here there's a view, there's a text component. And then in the index and Android, you can do the same. So two different entry points, but they can definitely share components. So if you have a really high level component, you can just put it in here, and it'll be shared between the two platforms. And that's it. So you can write your React components, and the way you would usually do. You just have to be aware of those gotchas that I mentioned earlier, right? So what you have access to, how do you apply CSS? Because in the end, it's not going to be CSS. So there's going to be, it's going to look a little different, but you can still figure it out. And that's it. And then if you want to deploy, you just run that command, React Native run Android. It's going to deploy to your phone right away, just like we saw earlier, very much like Cordova. And then you'll see the app running on your phone like this. Yeah. Good. Any questions on this? No questions. Okay, good. So let's move on to progressive web apps. So progressive web apps aren't really about mobile development, but they bring in together a lot of technologies that we can use to make mobile websites a lot more appealing. And one of those technologies is about installing the app to home screen, okay, or prompting the user to install the app to home screen, in which case it almost behaves like a native app. You can just add it to home screen, it's there, and if you want to uninstall it, you can just uninstall the normal way. And so it's a nice approximation of the native application. And because browsers are getting better and better at accessing those APIs like camera and things like this, and push notifications, then you can still get a lot from a progressive web application. So you can have a look at the list of features here. But basically, progressive web apps are a bunch of things that are put together, and it's kind of it's kind of like the result of everything we've learned from mobile websites put together. So you'll have responsiveness, right? So this is about fitting to the screen that you're on. You'll have progressiveness, which is about offer a basic experience and then enhance if you can. If the screen is Retina, offer better pictures. If the browser supports grid, then use grid. Use CSS grid if you can, that kind of thing. So you offer a basic experience and then you progressively enhance if the APIs are available to you. So that's good practice as well. There's also connectivity independent, right? So a lot of the appeal of a progressive web app is that a lot of it can work offline. Okay, so they use service workers, which is a new thing. It's actually not yet in Safari, but it is in Chrome and I believe Firefox, or maybe on its way in Firefox. And then with service workers, you can cache and you can allow your app to work offline. So you can cache results from network requests, and you can serve that up later. And you can also tell the browser what it should do if it's offline. You can tell it to load the right HTML file to get started and that kind of thing. And yeah, that's it. And here it says installable. That's what we talked about earlier. So this is about prompting the user or allowing the user to install their progressive web app to the home screen. So the user doesn't really know that it's a progressive web app. It's just an app. It's just a website, and they add to home screen, and that's it. So yeah. So the pros of these PWAs are that it's strictly HTML, JavaScript, CSS. There's no surprise. It's everything that we're used to, and that's it. So that's good. You can just reuse your knowledge. And a pro is that another pro is that you can just serve it on the web, right? So you don't need to pay the App Store or the Play Store. You don't need to rely on a third party to distribute your app. It's just a website, right? So in that way, it's more direct. And if you do want to be part of the Play Store or the App Store, you can also do that. You can also wrap your app in a web view, much like Cordova, and then you can get that as well. And yeah, and the service workers is a pretty interesting technology. So you can cache things and make your app generally a lot faster. Yeah, and then you don't have to go through all these bullet points for your first version, right? You can start with an app that is responsive, and then later you can make it. You can use service workers to make it work offline, and then later you can progressively enhance. Right? You can just choose which feature you want from progressive web apps and work on each feature piecemeal. So it's not a problem. It might look complicated, all these new things, but you can just take them one at a time.
Hey, Matt.
Mm-hmm.
Do you have an example that you could link us to, like a GitHub example, where we can pull down one of these, like a simple boilerplate or something like that for this PWA?
Yeah. So if you look at the homework for lesson 8, there's a link to a Google tutorial, and that's probably the best place to start. It's this one here. They'll walk you through the app. And I suspect they have a repo here. Yeah. Simple code here. Yeah, so there you go. There's a GitHub there. So you can have a look at that. That's a pretty good tutorial. And they'll go through what it means for the app to be progressive and how to do that yourself. So that's pretty good. What's next? Yeah. So in terms of cons, it uses a lot of new stuff. So service workers are not available, as I mentioned, and because all these technologies are new, you might find that getting help or documentation is kind of difficult to read because it's all new. But that should get better over time, hopefully. And then performance is only as good as the browsers, so that's kind of in the same category as Cordova. The browser is pretty good. I mean, the performance is pretty good because browsers have gotten better, but still, it's not native. And that's it. And so yeah, so if you have a look at service workers, so here you can use the caniuse.com website, right? And this is the state of the service worker support. So you have Firefox, Chrome, Opera, and Safari. IE Edge is not there. Right, so the support's not there yet. So if you're looking for a wide distribution, maybe your app is only going to work offline on some platforms. Right? So you have to be aware of that if you choose progressive web apps. Good.
Hey, Matt. I heard that not only service workers don't work in mobile Safari, but notifications as well as what else? What is it? Oh, the install prompt. None of that work on iOS. Has any of that changed? Do you have any sense of that changing soon?
I don't. You can. So yeah. So here there's a link that you can click to see the status of different browsers. I mean, it looks like so. WebKit that's probably mobile Safari. It says under consideration, right? So it doesn't seem to be actively in development. So you might think that that's not so great if you want to use service workers. But you can also, I mean, the idea is to progressively enhance, right? So if the service workers are not available, don't use them. Or just provide a basic experience. And if the user is on a platform with service workers, then you use them. When it comes to push notifications, so yeah, it looks like Safari here isn't doing so great. So yeah, I'm not sure here. There doesn't seem to be any development here. So yeah, I mean, I usually just go to caniuse.com and see what they think. It looks like Safari supports a custom implementation here. So that's usually where I get my information when it comes to browser support.
Okay, cool. Thank you.
Yeah, good. Yeah, good. So these are the three options that I see for mobile development: Cordova, React Native, or progressive web apps. Do you have any questions on this, or maybe you know of a fourth option? Yeah. Have you used React Native or Cordova before?
I was just able to build my first Cordova app. We were talking about this last section, so I got it running on my Android phone now.
That was fast.
Yeah, it was cool.
Yeah, good. Okay, so good. So then I'll let you choose what's next. Do you want to talk about browser testing or functional programming?
I would go for
Functional programming.
Functional programming, that's what I heard. Yeah, good. So let's go with functional programming. Right, so functional programming is usually, like historically, it's been linked to other languages. Maybe you've heard of something like Scheme or Lisp or Haskell. So these are functional languages, and they, at the very basic level, they just follow a lot of the functional principles. Okay, and when you use those languages, you end up writing code that looks a little bit different. Right? So you can still do all the things that you want to do, but the look of your code is going to be different. So we are going to talk about what that means. And for the world of JavaScript, it's also something that we can use as an inspiration. Right? So we can take the learnings from functional programming and apply them into JavaScript. Because JavaScript is not a functional programming, doesn't mean that we can't do functional code. We can still use a lot of tools that would be used by a functional programming language, and just use them, apply them in JavaScript. That's okay too. It doesn't work as well as it would in a functional programming language, but we can still do the best of it and learn from these functional languages. All right. So what does it mean to be functional? Okay. So I'm gonna define this as these three features here. So we want to write functions, or we want to write code with no side effects. Right. So your code takes inputs and it creates an output, and that's it. There's nothing else happening. The inputs won't be changed by being passed to this function, and the output will be a brand new object that didn't exist before, and there won't be side effects. Right? So So that's what that means. Every time you create an object, it's brand new. It's almost like everything's a constant. So state doesn't change. State is avoided. So you treat your code you treat each variable as a constant, basically. So that's what I mean by no side effects. The second point here is we want to write functions that perform a small task that can be reused. So the idea is that we'll architect our code so that we have different pipelines or different functions, and then when comes the time to write a new feature, we'll take some of these functions or some of these pipelines and we'll glue them together. Okay? So instead of having objects and collaborate in between those objects and having one object call the other, we're going to be thinking about small tasks or small pure functions that we just glue together to create pipelines. And the third point here is glue functions together to achieve the desired output. Right. So the idea here is that we are going to treat a function very much like a top-level construct. Right. So we will pass functions around back and forth. We will create new functions on the fly. We will take a function, give it one parameter, and then later give it a second. And then when it has all three parameters, it's going to run. That kind of thing. We are going to treat functions like a first-class citizen. Good. So one thing that is pleasant and easy to do in functional programming languages is to work with collections. Okay. So that's why I think the first step to mastering functional programming is to master map, reduce, and filter. So these three functions are available in JavaScript without any special library. Okay, let's just start with map. All right, so you might have seen map before, but the idea of map is that it will take a list and a function, or actually the list is the receiver. So it'll really just take a function and it will apply the function on each element in the list. Okay. And whatever the output of that function is for each element, map is going to take all those outputs and create a new list from it. All right? So it's a list operation. You start with a list, you apply a function to all the elements, and then you output a new list. Right? And the output is a brand new list. It's not a transformation of the initial list. Right? The initial list remains the same. It remains constant throughout this operation, and you get a brand new list. So that's what's happening here. Let's have a look at what that looks like. So here I have my input list, which is just an array. So when I say list, I mean array. So here we have an input array that contains 1, 2, 3, and here is my function increment. Okay, so at an abstract level, this is really just a function that takes a number and increments it. Okay. And that's it. So I can declare that function separately, and I can reuse it in different parts of my code. But here, I'm using it to increment each element in my array. So if I do input.map increment, I get a new list that will be the result of applying that function to every element. So 1, 2, 3 becomes 2, 3, 4. And the initial list remains the same. It doesn't change. So you might be tempted to see map kind of like a for loop, right? And it's sort of the same in the sense that it goes through each element in turn. But I like to think of map as a list operation. Right? So you use map to get an output list from an input list, and what maps the first list with the second is the function that you pass it. And I find that this view of map is clear. It's higher level, and I tend to write better code when I think that way.
Is it primarily for filters, Matt? Map?
Right. So map is really just to go through each element. Right. So filter is something else, and we're going to talk about filter in a couple of minutes. So let's have a look at a more like a more real example. So here I have a list of users. So this is something that you might have yourself. It's just a list of users. It's three different objects. Okay, and I want to print their names. I want to print all the names. Okay, so I can use map for this. I just need a function that will take a user and extract its name. So that's what I'm doing here. This is my function, my extraction. I'm taking the user and extracting the name. Okay, and I'm mapping that function over the users, so I get a list of names, and then I print them. That's it. So this is, I find this code a lot nicer to look at, and I think I'm faster comprehending this code because there's no for loop. I don't have to read through the for loop boilerplate, and this function can be reused, right? It's just a way to extract the name. There's a lot of high level ideas here, and for me it's easy to read. So I think functional programming is a good way to write code that is higher level. And as you do that, as you write more functional looking code, you get better, and then you just read code faster. Good. So let's see. Yeah, good. So yeah, so we've talked about for each and how fairly similar it is. Let me hide the solution here. So here we have 2 lines of code. Okay, we have a list of users again, Bob and Alice, and we want to print their name. So here I'm using for each. Okay, users for each, and then for each user, do this. Okay, console log u.name. Okay, so this is using for each, and it's not typically functional. All right, so how would you rewrite this code to be more functional? Does anyone know? Any idea?
Are you just referring to the rewriting it like the code above, where you reset another variable and use map?
Yeah. So we want to take for each and replace it with map.
230.
So that's definitely a good start. Let's see what that could look like. So here we have the users again, and here I'm using map, users map, and then this function extracts the name. Okay, and then after map, I have a list of names, and I'm just using join to join it together into one string. Okay, so hopefully with code like this, you get some idea of a pipeline, right? So the input is a list of users, and then you apply different operations. So you have a function that extracts a name, and then you have map, which will take that function and apply it onto your list. And then you have join, which will take a list and give you a string. Okay? And then the last step is the console log. So you can start reading this code as just a series of steps that follow. And if you want to know what the code does, you can just have a look at the last step. So here in the order of execution, the last step is going to be the logging to the console. So it just makes it easy to think about, right? So the input is a list of users, and the output is a logging to the console.
Which pharmacy did they put it to?
Which makes a lot of sense. Whereas here, it's not so clear what is the input, what is the output, and the console log happens once for every user. So at least to me, I don't get this nice feeling of just functional steps following each other. And this code is pretty simple. As your code gets more complicated, I think the value of doing it like this becomes greater. Good. So let's move on to reduce. All right, so reduce or also fold is just a way to take a list and to fold it and get an output from that list. Okay, so the input is a list, the output is a scalar or just a value. It's no longer a list, it's just a value. And the first example that you'll see when you read about reduce is always this one. It's about summing numbers, right? So you have a list of numbers and you want to know what the sum of those numbers is, right? So you can use reduce for that with the add function. So if I reduce this array with the add function takes two numbers and gives you the addition of the two. All right, so reduce will just go through the list. It'll take the first two objects, use add, that'll give 3, and then it'll take 3 and then take the next item from the list and then use add, and that'll output 6. And then because we're done with the list, 6 will become the result of the reduce operation. So that's how reduce works. You call reduce on the list and you give it the function that you want to use to reduce. So how would you calculate the sum in JavaScript? It would be something like this. So here we have the numbers and then reduce sum n, sum plus n. The idea here is that the first parameter, that's going to be the result so far. Okay, so in the example, our first intermediate result was 3. Okay, so that would be sum. And then the next time around, when the function is called again, sum would be 6.
Hey, Matt, if you say multiply, will it do multiply? Basically, it's a function, right? That you're using like sum.
That's right. Yeah. So this is the sum so far. If you wanted to multiply, you would have to change this plus to an asterisk, and you would have a reduce multiplier. Yeah. So reduce is really just calling this function again and again on each element in the array, and whatever you returned last time from that function goes into the sum parameter. And that's it. That's how it works. Let's see a more real life example. So we have a list of videos here. We have 3 videos. They're just JavaScript objects, and we want to sum total views for all those videos, right? So you can imagine that those are all the videos from one user, and we want to show that user their total views. So we can definitely use reduce for that. Here I have a function called SumViews. It accepts the videos as input, okay? And here I'm using reduce. So I'm taking the list, I'm calling reduce. This is a total of views so far, and this is the view object, right? So reduce is going to give me all the objects in turn, and then all I have to do is calculate the total number of views so far. So I can take the current views from the v object, from the current view, and then add them up with the total, and that's it. Now the only question is, what is total in the beginning? And that's what this 0 here is about. So the second parameter to reduce is the initial value. So here, the first time my function's called, total is going to be 0 because that's what I passed as the second parameter, and then v is going to be the first object. So 0 plus v plus views, that's going to be 321. Okay, so the second time around, my function is going to be called. Total is going to be 321, and v is going to be the second video. So on and so on until we get to the total views. And that's it. And then here you can see a mini pipeline. Okay, so I'm logging some views and passing in videos. So the input is here, and the output is the logging to the console. Right? All these pieces fit together in one pipeline.
So Matt, would this obviously be useful like in an analytical situation where you wanted to see how many cat videos for the last 3 months or in the month of March, something like that, where you could say filter by this parameter and then reduce it?
Mm-hmm. Yeah, for sure. And all your filters, all your expressions to filter or map or reduce, you can declare them. They don't have to be anonymous functions. Right? You can declare them as functions, and then whatever you need, at some point you have a lot of these functions, a lot of these utilities that you're building up, and yeah, at some point you get to a level where you can just pick your functions, glue them together, and then you end up with one-liners like this. Yeah, and then, yeah. So if you wanted to see only cat videos, then you would have to use filter. Right, so this is the third functional tool, and then filter is really just about taking the list and creating a new list that will contain only the elements that you want. Okay, so once again, the input list is not changed. Okay, we get a new list, but it will contain all the elements from the input list that you care about. So the first example that you see is always this one. It's about extracting even numbers. So you start with 1, 2, 3, 4, and then you use filter. And then this function will tell you whether yes or no the number you pass in is even. And if it is, if the number passed in returns true, then filter will take it and put it in the output list. Okay. So here we just get 2, 4. That's the output. Good. So this function here is a predicate, right? It's a test. It takes in one element and it has to return true or false. If you return true, that means keep the element. If you return false, that means reject the element. Don't make it part of the output list. Good. And so yeah, so here for a more real life situation, we still have a list of users with a name and a donation. And the idea here is we want to get all the users that donated any amount of money. Okay, so we want to thank the contributors. All right, so the first thing that we're going to have to do is just take that list and filter to only keep those that have a donation. Right? So either this user, Alice, or Elliot. Okay, so here I spelled it out. Right, I am not using anonymous functions here. I have a get contributors function. Right, and so this function is just taking a user and returning whether true or false, yes or no, this user is a contributor. Okay, that's like a small component in my pipeline, and this is the get name piece, which will just extract a name from a user. Okay? And then here in the last line, we just take all these pieces together into a mini pipeline here. So I'm taking all the users, I'm filtering with get contributors. So the output is going to be only the contributors. And then I'm mapping over them because I want to extract their name. Okay, so map get name. So I get a list of all the names. And then I'm using join to take all those names and make a string from it. And then all this goes into a thanks to blah, blah, blah string that I alert. Right? So if you want to know what this code does, you can look at the last line, and you can quickly get a sense for what this code does. Right? It's very high level. Good. So if you want to use functional programming, by all means you can just do it now. You can use MapReduce filter already. It's basic JavaScript, but you might want to do a bit more. Maybe you want to work with lists in a way that's a little smarter, or maybe you want to play with immutable data structures. Right? All these would be functional ideas. I think it's a good idea. It's something that you want to incorporate into your coding, and it will make your code easier to read. It's going to be a higher level, but also because functional programming is more about keeping things constant and not modifying state, then you'll have fewer bugs in your code. Because right? a lot of bugs come in whenever your state changes in a way that you didn't expect. And then later on, your code doesn't really know what to do with some of the values for your variables.
Would you use this type of function? Let's say you're ranking variables. You have an initial list, which you really don't want to change. You just want the output to be ranked. So you want to recreate the list, but ranking it based on, I don't know, any one of multiple different parameters. Is that where this comes in handy? Or is that still a for loop?
Yeah, it could definitely be used there. So you would be sorting. It's a kind of a sorting exercise, and you could definitely do that with a functional mindset. So you could have a function that takes two elements and decides which one should be sorted first. So that's a single function, and then you could sort using that function, and the output list would be the sorted list, and the input list stays the same.
Thank you.
Yeah, so that's also a good example. And yeah, so if you want to do a bit more, if you want to get into it, then have a look at the Lodash library. It has a lot of utilities, and you can just go into it and add it to your project and use that. It's very popular. Yeah, good. And yeah, if you want to test yourself, there are a lot of katas on code wars about functional programming, map, reduce, filter. You can also have a look at this CodePen. So here, the HTML and CSS isn't all that interesting. All we have here is a div with ID display. Okay, and then let me maximize this editor. Let's do this. Good. So yeah, you can have a look at this this CodePen. I won't do it now, but you have a list of users, and then the idea here is to display the top 3 users by total karma in the video category. Right? So these users have different categories, video or audio, and we want to filter to only get the users from the video category, and we want to reduce to get their total karma, and then we want to take the first 3 of that and display it. Right? So that's an exercise that will allow you to use map, reduce, filter. And if you want to display your top users, you can just use this function. This will just take the list of users and display them onto the page. That's it. So you don't have to worry about the UI. This function does everything that you need to do. You can just write your functional code here and see if that works for you. Good. So we have a few minutes left. So I think we can just talk about browser testing. Let's see. Yeah, good. Good. So we've talked a little bit about testing, but we've done only unit testing in the sense that we were writing a test, and the test was calling a function, and it was expecting something on the output of that function. So maybe there's a function to get an item from the catalog, and so the test would maybe create the catalog, call the function to get the item out of the catalog, and expect that the item retrieved was the right one, something like this. So that kind of testing is really easy to do. It's really fast to get feedback from. Right? You can just run your test, and it goes really quickly, and it gives you a lot of confidence that your code is working nicely. But it's also very low level. Right? So if you have different modules interacting together, or if you have a browser with a UI, then the user is kind of also in the picture, in the system. So if you just do unit testing, you don't get that extra confidence that you would get from testing the user interaction, from testing your app manually, or from testing different modules interacting together. Right? So you can add tests onto your test suite that will be at a higher level. And so browser testing is one of the highest levels that you can get to. All right, so the idea here is that you are impersonating a user. So instead of calling functions and making sure that the return value is correct, you're actually clicking things on the page. You're clicking buttons, you're filling out forms, you're clicking links, and then at the end of your test, you might expect a thank you page. So maybe you have a test that tests the shopping cart workflow. So maybe your test starts with searching for a product, adding it to the cart, ordering, and doing the checkout, adding credit card number, and then clicking confirm. And then the last screen should be a thank you page. Right? So you have all this workflow mapped out. And with browser testing, you can just test the whole thing in an actual browser. So you'll be running code that will enter characters in a box, click buttons, things like this. So here's what that looks like. The tool that I'm using here is probably the best tool for this, Selenium WebDriver. And so if you use that to drive your browser and a test runner like Jest, then you're good to go. Right? So Jest will give you a way to write your tests and to run them, and then Selenium WebDriver is giving you a way to drive the browser. Good. So here's a simple example of what that looks like. I'm declaring a bunch of things here. Maybe that's not so important. And the test is here. Maybe it looks a bit complicated because there are a lot of promises here. Potentially this code will be simplified with async await. But for now, that's what it looks like. And basically I'm using the WebDriver, the driver here. and I'm saying go to Google. Okay, so it's going to type that URL in the browser and go there. When that's done, it's going to find the element by name Q. So it's going to look for an input name Q, and then it's going to type WebDriver. Right? So this test is impersonating the user, typing WebDriver in the box, and then I'm clicking the Google search button here. And then so the browser is going to do the search. And here I'm waiting until the title is this, the title of the page. Right? So yeah, so when you're impersonating the user and when you're driving the browser, a lot of the operations won't be real time or won't be synchronous, right? If you click a button and you do a Google search, it won't be immediately available to you. So you have to be a little careful, and often you have to do things like this. You have to wait until something happens, and then you can keep going. So here we're just waiting for the search to be done, to be performed, and then in the end here, I'm doing driver get title, and I'm expecting that title to equal WebDriver Google search. Right? So we just have a test here that will do a search and make sure that the page style changes. Right? Maybe this isn't the most important thing for Google, so there's probably not a test that I would put into my test suite, but you could easily extend this test, maybe click the first result, and that would be already a very useful test. Yeah, so what's amazing about these tests is that you get real confidence. You're actually using a browser. So all the integration points are being used. You can run this code in different environments, right? So you can run this in development, in staging, that kind of thing. And so you get a lot of confidence. It's kind of like manual testing. It's kind of like opening a browser and testing for yourself. But manual testing is tedious, and this is more reliable and faster. So you can have a look at this repo for an example. Let me see if I can run that code here. What's it called? WebDriver just. Oh. That's just okay. Yeah, good. Sorry. So browser testing is here. Yes, good. So yeah, so here we have a minimalist example of what that would look like. So I have some so yeah, I have an example here. That's less interesting. So here's the test that we just looked at in test.js. Okay. So I want to run this. Okay. I have jest installed here in my package.json, and if you look at if you look at package.json here, I'm using the scripts command here. Okay, and so maybe you haven't seen this before. This is quite handy. If you declare scripts like this, that allows you to create shortcuts for certain operations. Right. So here I have 3 different scripts, and if I run yarn run test, which is my 3rd script here, it's actually going to run this command on the right. So it's going to run path jest test.js. So instead of remembering this command, I can just remember test. And now I can do yarn run test. Or was it plural? Sorry, test. And that's it. And now that command is going to run. So it's a nice entry point for running that. So jest is going to start up. Hopefully you'll see Firefox firing up. And that's it. So that's the browser automatically managed by the test. It loads Google, types in WebDriver, the page style changes, the test is passing. That's pretty good. Gives you a lot of confidence that the website is working. Yeah. Good. Any questions on this?
So Matt, is the test suite that you recommended is equivalent to like what we have, like Jasmine and other test tools? This is like an alternative to that?
Yeah. Yeah, Jasmine is perfectly fine. If you want to use Jasmine, that's good. Use Jasmine. Here I'm using Jest, which is like Jasmine, but it's also a bit of a test runner. So I use it to run the tests. And this output, which I like, is also coming from Jest. So it's an alternative.
So again, what is Selenium is doing, the role for Selenium in terms of Jest?
Right. So yeah, they're two different projects, and you can use them separately. I just have this minimal example here, and I like Jest, so I'm using it here. Selenium WebDriver is driving the browser. So it's opening the browser, and it's allowing you to say, go to that page, click that button, do this, do that. Right? So if you look at the code that we had here, when I do driver get, I go to that URL. When I do find this element, send keys, when I do click, all that is Selenium WebDriver. Right, so everything that's browser related, that's Selenium WebDriver. Everything that is test related, like it or expect, that's Jest.
So we can give, instead of Google, we can give our application, right? And we can use WebDriver.
Yeah, so here I'm testing Google. Right? So for your own project, you'd be testing maybe localhost something, or maybe your staging environment, right? But you'd be testing your own app, and you'd be testing your checkout workflow. You'd be testing your sign up workflow. You'd be testing your login, logout workflow.
Got it. Thank you.
Yeah.
And you can use it to test any browser, Safari, Chrome, or is it just specific to Chrome?
Yeah, so here we sell Firefox. That works well. You can also do it with Chrome. I haven't done it with any other browser, but I think you can. So you could have a look at the documentation from Selenium WebDriver, see which browsers you can test. If you like that, you can also look into services that will offer testing on different devices or different operating systems. So you could run this test in under Windows or Linux or Mac, that kind of thing. And yeah, you have different services like Sauce Labs is one, or Browser Stack, and they'll just allow you to test in these different environments. And some of them even have native devices, so you can run your tests on a device somewhere. Yeah, so you don't have to, in that scenario, you don't have to have every phone with you that you want to test on. You can just outsource that to a service, which is quite nice. But once you start doing that, it's pretty advanced, and it requires a bit of setup. But yeah, but it's a nice thing. It's a nice possibility, and even though the accessibility of that feature or those features is not so good, it really requires a lot of setup and a bit of coding. Maybe it'll get better over time. So yeah, but it's a nice thing because it's the real deal, right? It's the last test that you're ever going to need. Right? You're impersonating the user. So if your test is working, that's it. You're good. Good. All right. So that concludes the JavaScript course. I hope you learn a few things. If you want to keep a copy of the class notes, you can download the PDF. The link is in the Slack channel. You can also have a look at the last homework. So for lesson 8, whoa. What's going on here? Yeah, for lesson 8, it'll have a few notes about what we talked about today, and it will also have recommendations on how to improve, and a few links here that you might want to have a look at. Now that you've gone through this course, you might find these links interesting. And hopefully they can just open up your horizon so you know what to do next and what to focus on. And yeah, my advice is to learn by doing. So you can read a lot of books and you can listen to a lot of people, but you learn most, I think, when you're actually building something. So find something that you want to build, that you want to work on, and just work on it. Learn as you go. So if you realize that you need to know about the virtual DOM to continue, then learn about the virtual DOM and come back to your app and build that. And if you feel like you're a beginner, that maybe you're not good enough to get started, just pick something simple. It could be a command line application with Node. That could be really simple. That could be 5 lines that do something interesting. Or yeah, just pick something simple and work on it, and you can build more complex things over time. And yeah, and if you do build something interesting, feel free to come back to the Slack channel and show off to everybody. Yeah, good. Any final questions? No? Okay.
Thanks.
Well then, yeah. Well, thank you. And,
Thank you very much, Matt.
Yeah, thanks so much.
Thanks a lot.
Thanks, Matt.
Yeah.
Thank you, Matt. I missed you already.
You did a good job. Yeah.
All right. Good. Well, thank you.